Hi everyone, today's video will be a great summary of all solving methods. If you notice here, the title is, which method should I choose? Because as of now, we have several different solving tools in the toolbox. And to know which one to use, we have to be able to identify what type of question we have. So let's first answer this question, why do we solve? If you have a highlighter, I'll be highlighting these titles to make them stand out. So why do we solve? The whole purpose of solving is ultimately to find the value of x. We're trying to solve for x. If the equation is set equal to 0, these values when I say these values, I mean these x values or answers are the zeros which are the x-intercepts on the graph. Making a connection to our real-world scenarios, when you set a quadratic equal to 0, so like let's say I had this quadratic, a rocket's being launched from the ground and it lands back on Earth, we would set our quadratic equal to 0 and solve, because what you were really finding was those x-intercepts on the graph. Now that we've kind of oriented our thinking with why we solve, let's now get into the 3 tools in the toolbox. Our first tool is solving by square roots. So let's highlight that. When do we solve by square roots? This method is used when the equation is missing a bx term, and I put that in quotes. And when we say bx term, we're really saying middle term. That's how we usually think of it. The middle term of ax squared plus bx plus c. So we're saying the bx term, or that middle term, is not there. So to solve by square roots, we need to, 1, isolate x, isolate the x term, and then 2, take square root of both sides. Don't forget that when we do that, we get 2 answers, plus, minus, positive and negative. So to summarize this off to the side, let's put in a big box, no bx term. If you have a different color highlighter, maybe notice how I changed colors. Make that stand out. So when there's no bx term, when there's no x term, middle term, however you like to think about it, we will always solve by square roots. Next is solving by factoring. So let's highlight that. We use this method when, so you can either write this method is used or just start with when we have ax squared plus bx plus c. So notice now we have the middle term. So let's go over our steps. 1 must be in standard form. And set equal to 0. Step 2 depends. Remember, we have two situations. We have a equals 1. So when a is 1, remember factors of c that add to b. Here I'm just abbreviating the key idea. You can go backwards in the workbook and go look when we factored when a is 1 for more notes. So if a is 1, we're looking for factors of c that add to b. Notice I changed colors, so you have a highlighter, highlight that, or if you're taking notes in pencil and you have like a blue pen or a black pen, go over that to make it stand out. If a is not 1, we will need to guess and check. Outer, inner equals middle. Once we have factored, set each factor equal to 0 and solve for x. So in summary, off to the side, for when do we factor? When we have a middle term. The last tool in the toolbox is solving using quadratic formula. We use this when we have ax squared plus bx plus c. So once again, we have a middle term. And cannot factor. So our go-to method will always be to factor. But if we can't factor, if we cannot factor, we are going to use quadratic formula. So for example, a lot of our real-world quadratics were very messy numbers, so to speak, lots of decimals. Sometimes we had fractions or just very big numbers. So instead of trying to factor those, we just went straight to the quadratic formula because in most cases, those were actually not factorable. We would get decimal answers. So let's make a note. If you cannot quickly factor, so we've got decimals, big numbers, or just not factorable. Like we could have smaller numbers, but it could not be factorable. Step 1 is the same. Must be in standard form. Standard form. And equal to 0. And then step 2, quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Keep in mind, it's all divided by 2a. I see that happen sometimes where people will only create the fraction bar like this far and then think that negative b is all by itself out front. That is not the case. Negative b is part of the numerator. So in summary, we use quadratic formula when we have bx term, we have a middle term, and can't factor. We have a middle term and are not able to factor. So let's get into some practice examples here. I am going to do only a couple. I'm going to do one of each. So one that requires each of these 3 tools in the toolbox. And then I will ask you to try a couple, and we will wrap up the rest of the practice as part of our independent practice tomorrow in class. So we are going to do numbers 1 and 2 together. I would first ask you to just take a moment and compare number 1 and number 2 and think about what makes them different. There's something that is a big difference between numbers 1 and 2. Can you see it? Can you find it? Take a second and think. So looking at 1 and 2, the first thing that jumps out to me is that this one has, I'm just going to highlight this real quick, you don't need to do this, but notice, number 1 has a middle term, has an x term. Number 2 does not. So as soon as I see that we do not have a bx term or a middle term, what tool in the toolbox will we use for number 2? When I look, if I do not have a middle term, we will solve by square roots. So I'm going to make a little note to myself over here. We are going to solve this one by square roots when we get to it, because there's no middle term. Coming back over to number 1, because I have a middle term, the last 2 tools in the toolbox apply. My first method will be, can I factor? If it's not factorable, I'll have to do quadratic formula, but hopefully it's factorable. So let's see. To be able to factor, we must have standard form, and this must be set equal to 0. See if I can leave the steps on there for a second. So let's check. This is not set equal to 0 yet. To get this set equal to 0, what has to move? That 14 needs to move. It's a positive 14, so I will subtract 14 from both sides. There are no like terms here, which is okay, so I get x squared minus 5x minus 14 equals to 0. Equals 0. So we've accomplished the first step where it says it has to be in standard form, highest power to lowest, and equal to 0. Now we have to decide, is A 1 or is A not 1? And when we talk about A, we're talking about the number in front, the coefficient of x squared. So I know that technically there's an invisible 1 out front. So we are in the A equals 1 part here, where we're going to be looking for factors of C that add to B. So we can make a note off to the side, A equals 1, factors of C that add to B. So for us, that would mean two numbers that multiply to negative 14 and add to negative 5. So I might keep track of my thoughts here. When I think of 14, I think of 7 and 2. I see that C is negative. To multiply to a negative 14, 7 or 2 has to be negative. And if I'm trying to add to a positive 5, which of these two numbers should be negative? If you're thinking or saying 7, I agree. So this will factor to be x minus 7 times x plus 2, and again, still equals 0. So next to number 1, I'll make myself a note that I was able to factor this. If factoring had not worked out, what would I have had to do? If I was not able to factor, what tool in the toolbox would I use? Well, looking at our notes, if we have a middle term and we can't factor, we would have needed to use quadratic formula. But that's not the case for number 1. We were able to factor, so let's go look. We just factored. Now we're going to set each factor equal to 0 and solve for x. What will that look like? Well, when we say factors, this is a factor, and this is a factor. So we'll take x minus 7, set it equal to 0, and x plus 2, set it equal to 0, and we'll solve them one at a time. X minus 7 equals 0. I will add 7 to both sides. Here we get x equals 7. And then here, on x plus 2 equals 0, I will subtract 2 from both sides, and we get x equals negative 2. I have successfully finished solving for x. Making a connection to our prior knowledge, this didn't ask us to sketch a graph. We're done when we found x. But remember what we wrote about why do we do this. So we just found values of x. If the equation is set equal to 0, these x values, are our answers, are the zeros, which are the x-intercepts on the graph. So to solve this, we did have this set equal to 0. So that means the zeros are x equals 7 and negative 2. Remember, this is a list, not an ordered pair. And if I look at my quadratic, it's a positive a. So how will the graph open? Opens up. So this is actually all the information I need to, if I wanted to draw a very quick sketch. I have one x-intercept at 7. I have another x-intercept at negative 2. And again, because a is positive, I know that this opens up. I technically have the skills to find vertex, but I wasn't asked to, and again, we're just doing a quick sketch. So this is what our graph would look like approximately. Again, quick sketch. But it's important to me that we understand the connection between these two answers and what the graph would look like if I were to graph this. Let's now take a look at number 2. Remember, we had started our conversation with comparing numbers 1 and 2 and noticed that number 2 did not have a middle term. No bx term in the middle, or anywhere actually, didn't have to be in the middle. I just have an x squared term and numbers, which means I don't have to worry about factoring. I can solve by square roots. So let's go look at those steps. To solve by square roots, let's recall that first I will need to isolate the x term. So wherever the x term here is, x squared, I need to get it by itself. So I'm only going to pay attention to this side of the equation right now because that's where my x term is. what am I going to do first here on the left side? Well, I recall we are working PEMDAS backwards. So if I were to write PEMDAS, to solve, we work PEMDAS, that's a horrible arrow, backwards. So if there's something I can add or subtract, I'm going to take care of that first. Do you see something on this left side that I could add or subtract first? I see that -4. I'm going to choose to add this to both sides. So I get 3x squared equals, what's 23 plus 4? 27. Nothing else I can add or subtract here. So next I say, is there something I can multiply or divide by? Well, I see that this says 3 times x squared, and I know that the inverse operation of multiplying is dividing. So I can divide both sides by 3, and I get x squared equals 9. As of this step, my middle term, or excuse me, my x term is isolated. It's all by itself. So once we have isolated the x term, we are going to take the square root of both sides, and don't forget plus minus. So the inverse operation of squaring is square rooting. I will take the square root of both sides, and I get 2 answers, positive and -3. As a quick reminder as to why the plus minus, it's because 3 squared is 9, and -3 squared is also 9. So if you think about x squared equals 9, we're answering y when I take the square root, I get 2 answers. It's because there are 2 answers for x that get me a 9. 3, positive 3 squared is 9, as well as a -3 squared is 9. If you're using your calculator to try this out, remember that we need to use parentheses. Looking at number 3, we're mentally going to keep track of our toolbox, by the way. So up in the upper left corner, let's just make a list of the 3 tools. It's either going to be solving by square roots. I'm going to make this less chunky so that I can fit them all. That didn't work. Try that again. So recall the toolbox. 1 is solved by square roots. 2 is factor. And if it's not factorable, quadratic formula. And I'm not trying to crowd that question, so maybe I put my toolbox right here in the middle. But that's our big picture. Every single question from this point forward in this activity will fall into one of these 3 categories. So for number 3, as soon as I look at number 3, I see a middle term. So as soon as I see an x term, I know that solving by square roots is off the table. We're either going to be able to factor or do the quadratic formula. So before I do that, what does this have to be set equal to? I know that before I do anything else, this has to be set equal to 0. So I will subtract 6x and subtract 8 at the same time. (5x squared) is still here because there is no other x squared term. When I look at this side, there's no other term with x, so I know minus 6x will also come down. And then last but not least, -3 minus 8 is a -11. Now set equal to 0. If you didn't like doing this at the same time, you could have done one at a time. Subtracted 6x, get the result, then subtract 8, get the result. We should still match right here. So don't, oh, the phone is ringing, sorry. pause this for 1 second. So once again, we now have it set equal to 0. And our first consideration here is we have the middle term, so we know we are either going to factor or use quadratic formula. If we can factor, we definitely want to factor. Looking here, I see that a is 5, 5, 6, and 11. There's no GCF, so this will be factoring when a is not 1. Guess and check. That means we're going to set up our two parentheses, so 5x and x. And when I say guess and check, I'm describing that process of the guess and check, outer, inner, equals middle. So when I look at 11, the only factors of 11 are 11 and 1. So maybe I try putting 11 here and 1 here. When I do the outer, that gets me 55x, and when I do the inner, I get 1x. No way is that going to add to 6. Not even close. So we will switch 11 and 1. So I'll put 11 here and 1 here. Let's see. The outer gets me 5x. The inner gets me 11x. C is negative, so I get to have one of these be negative. If I'm trying to add to a negative 6, if I make one of these negative, can I get that? Well, if 11 is negative, that gets me a positive, or yeah, that works. 5x minus 11x gets me negative 6x. So we ask ourselves, which got us the 11? Well, it's kind of more obvious here. So 11 needs to be negative. 1 will be positive. So I have successfully factored that. If you're able to see it there, no problem. If you want to rewrite it, it's 5x minus 11 times x plus 1 equals 0. Now that it's factored, we take each factor, set it equal to 0, and solve. I'll add 11 to both sides. We get 5x equals 11 here. Divide by 5. X equals 2.2. Here, I'll subtract 1 from both sides. X equals negative 1. Now, if guess and check hadn't worked, like I wasn't able to find outer inner equals middle, that's when we would have to say to ourselves, oh, okay, I can't factor this. Then I would use quadratic formula. Now, if you tried using quadratic formula on this quadratic, you would get to these same answers, but it would just be a whole lot more work. So just for emphasis, if you can factor, factor. If it's not factorable, then I will use quadratic formula. That finishes the notes for today, because the only skill we haven't seen here is if one doesn't factor, use quadratic formula. But quadratic formula is not a new skill for us, so that's going to stay in our back pockets if factoring is not possible. I would like you to try 2 on your own. If you could please try number 4 and number 7. I would put a note here. I do have a middle term. So my hint is get equal to 0 first. Remember that. Can you factor? If yes, factor. If no, quadratic formula. So we'll start off class tomorrow looking at 7 and number 4. I wrote a hint for number 7, so I probably should put a little one for number 4. My question to you for number 4 is, do you see a middle term? Do you see an x term? And the answer is no. So no bx term, or no middle term. This is going to be a solve by square roots. Nice job. If you want to take a picture of your number 4 or number 7 if you need help, please by all means shoot me a question on Remind. Otherwise, I'm looking forward to seeing what you get for answers for number 4 and number 7. Have a great night, and I will see you next class.